Here are two phases. Phase one. Here's the word obstacles. Here is so use the ones to write sentences about how the water level in this phase changes if is graph A for phase 1?
I don't know. So how would you, if you were just describing faster or slower, the height, or sorry, the depth of the water as it rises in terms of time as well?
So I think that phase 1 fills up faster.
So it, like, they might fill up at the same time, but like, so it's water depth here, then it's water depth here, then it's water depth here. It's going out, and so what's going to happen to the rate that it fills up at?
It gets slower.
Yep. And how about with phase 2?
It goes inwards, so it's faster.
And so which graph will match with which?
Would phase 1 be with graph B?
I think so, because that will get slower and this one will get faster. Yeah. The water level in phase 1 rises faster first, then slower. Yeah. And the phase 2 rises slower first, then faster. Okay. Let's see. How about this one?
So do I have to do A and B?
Let's just do B.
Okay. Which one best describes the relationship? Is it B?
I think it's B, yeah. So it's going to be faster. Yep, B. Okay. Let's see, let's try matching these 3 up.
Okay. So C is 3. B is a 1. And then A is 2.
That's it. That is it. Let's see, what would be the difference between the graphs for these 3?
So B would be just a straight line.
Yep.
Oh, wait, all of them would just be straight lines.
And so what would be the difference?
The width.
Like, I think, so which will fill up first?
B.
So how would that, what would the graph of that, how would that be different from the other ones?
it would be like, so it is a little closer to the y-axis.
Okay. And so how would you be able to tell A and C?
C would be below B.
And then where'd be A?
A would be the closest to the x-axis.
Yeah, well done. So let's have like the smallest gradient. Take the longest. BCA, something like that. Yes, grand. Okay, match up.
Okay. A and B.
Like that, is it?
Or B, no, B and A.
The B here with that, is it?
Yeah.
Okay.
Then is it A and B?
So the graph B has a sudden change in it. The graph C has a gradual change.
So C and B.
So that goes there. Yeah, because that's a sudden instantaneous change. And so this one must be this. It's like gradually changing. CAB, that's it. Oh, okay. How about these?
Okay. These ones. These are not each. So I think A is 1.
Okay.
E is 2.
D is 2. Okay.
3 is C. And 4 is B.
And so this one is C. This one is B. ADC B. ADCB. Hey, didn't mean the same mistake I did. That's weird. Okay, let's see. This one is fine, I think. For this one, so before, with a distance time graph, the speed is the rate of change of the car, and the way you do that is you'd get the gradient. If it's a curved line, you'd sketch a tangent at that point. So let's say at the 10-second point, you sketch a tangent to the curve and you find the gradient of the tangent at that point. And so any idea the gradient of the tangent?
So the tangent. I didn't really understand what you said when you were explaining what the tangent was.
Any idea how you find the gradient of the blue line there?
Yeah, you do rise over run.
Yeah. So what would be the rise over run for the blue line?
Let's say 4 and 4.
We could choose from here to here. So how much did it rise by?
Okay, 3 and 3. So the rise is 3.
Rise is 30. 10 to 40.
Oh, okay. Run is 20.
I believe. What's it?
Oh, the run is 10.
Starts at 0.
The one is 0.
15. 0 to 15. So it starts at 0, 10. Goes to 15, 40. So rose by 30, ran by 15.
Okay.
So what do you get there?
Then the gradient would be 2.
Yep. And so that is 2 centimeters per second. In distance time graphs, the gradient would be the speed. And when we're doing straight lines, it would be the gradient of the straight line would be the speed. The way you get the gradient of a curved line is you just draw a straight line at the point where you want to find the gradient. So you sketch a tangent. We shall try. Okay, so how do you do this one?
Estimate the speed of the run at 12 seconds into the race. So the speed is like 78.
12 seconds. That's the distance.
Oh.
The speed is distance over time or rise over run of a straight line if it was there. So we sketch a tangent at the 12-minute mark. 12-second mark. So it looks like it's about there. Okay. So what does it look like?
It looks like 78.12. 79.
So what's the rise? What's the run?
The rise is so the rise is 8.
That's the run.
Run.
And so you can always do like y2 minus y1 over x2 minus x1. So 12 minus 4 is 8. And the other one?
Oh, the other one's 78.
So I'm just going to estimate that that's 80. Just going to estimate that that's 80. So what would that be?
10.
And what would be the unit?
The units, distance times. So speed per second.
Meters per second. So this one is meters, this one is seconds. There we go, 10 meters per second, yeah. So that was supposed to be up to 80. It probably was 80. Okay, grand. We try. Okay, how would we do C?
That's not the difference in the speed. 50 seconds since. Okay. So you have to do ride the run here as well.
Mm-hmm.
Okay. So for Claire, 50.
So how would you start it?
So you need to make it into a straight line.
Yeah, so you sketch a tangent at that point. It's probably going to be something like that. That's it. Okay. So, what two coordinates does it go through?
It goes through 0, 20,
20, 0.
20, 0, and then 50, 50, 200, and 220 or something.
I think so. Okay. So what would you get there?
So you would get so you have to do, so for your run would be 30.
Yeah. I'm going to estimate it's 210.
Okay. And then your rise is 210. So your gradient is is it 7?
What's the unit?
The unit is meters per second.
Looks like it. Okay, so a 7.25. All right. So it was 220. Grand. Let's see. What would be question A?
Between which 2 months did the profit increase the fastest? Explain how the graph shows this. Read your answer to part A and describe the rate of change of it.
No, I crossed those out. Just part. Oh, the hint, is it? You don't need that.
Yeah. I didn't need the hint.
No, that's for part B. So between which 2 months did the profit increase the fastest?
On increased from January to March.
So that's like 3 months. Between month what and month what?
Between month 1 and month 3.
You can only pick between 2 months. Like a gap of 1 month.
Oh, so then month 1 and month 2.
Yes. And how does the graph show that?
Because they are going up.
They're going up. It's always going up.
They didn't. It's like they keep going vertically up.
Let's say steepest gradient or something like that. Because that's it went up by the most between those months. Here it's like slowing down. Let's see. The graph is steepest gradient in this section. Yeah, months 1 and 2. Velocity time graph. The acceleration is the gradient. Okay, so this is a velocity time graph. So let's try this one.
Okay. Gavin goes for Gavin's maximum velocity. How do you find the maximum velocity?
This is velocity on the y-axis.
Oh, so okay. So it's 1.6.
Yep. 1.6 b.
How many minutes you run out? You ran for like how do you tell how many?
So let's say each square is worth how many minutes?
So see, to get doubled, so each square is about 120.
Yeah. And so how many squares is it from Q to R?
3.
I think it's 2.5.
Oh, okay. I was rounding.
Okay. So it's like 2.5 of 120.
So 2.5 times 120. 6. Is it just 120?
So 120 is one square. 2 squares?
240?
Yeah. And half a square?
60?
And so how many minutes in total?
300.
And so how would you do C?
Okay, the acceleration for the first part of the journey. Yeah. Look at the steepness of the line.
Yep. So what's the rise? What's the run?
His acceleration. I don't really understand.
It would be the gradient of the line at the first part of the journey. Let me just see something a sec. What would this one be? First 5 seconds acceleration.
It was going up diagonally.
And so the gradient will tell you the acceleration.
So you have to find the gradient of the line.
Yep. For the first part of the journey.
Okay. So unit-wise, run. So the points is 0, 0, and 5, 1.0.
Yeah. What would be the gradient?
The gradient would be 5.
That'd be run over rise. Rise over run.
Oh. So. Um. 0.2.
Yeah, 0.2. Or 1/5. Yeah. Okay. How would we do this one? Question C.
Estimate the acceleration at time equals 4 seconds. So you need to make the straight line.
Yeah.
Point.
Looks like that.
So it would be 420, 420, and then 010,
and
then the run is 10.
Yeah.
And the rise is 4.
Other way around, I believe. The rise is 10.
Okay.
Runner's 4.
And you get 2.5.
So that's 2.5. And that is meters per second squared. 2.5. That's it there. That was question C. And D, describe. That just means in words. So how is the acceleration changing over the 12 seconds?
It just, the gradient keeps on going up. The steepness of the line.
The steepness of the line, I think, is going down, decreasing over time. Like it's kind of flattening out. Like it started up very high at first.
Oh, yeah.
And then it's kind of slowing down. The rate of acceleration decreases over time. That's it. This one is similar enough. All right. Similar enough, I think. How do we do? Maybe I'll keep it. All right. How about this one? Question B.
Question B, estimate the acceleration at t equals 40. Estimate. So you have to do a straight line, or you just have to guess?
Straight line, yeah. So t equals 40. Looks like it's about there. T equals 40. So like that or something.
So it would be 2540.
Yeah. 40-25.
Yeah, 40-25, and then 0-10. So run would be, the run would be 40.
Okay.
And the rise is 15.
So any idea about that one?
You get
You can. Oh, it's a calculator.
it's a calculator question.
Yeah.
Okay. So let me get my calculator.
Okay.
Okay. So 15 over 40. 0.375.
That's it. So that's 3/8 or 0.375 meters per second squared. And they rounded to 0.4. That's alright. This one's okay. Exam style question. I think you're okay. Okay, how would we do this one?
Calculate an estimate for the gradient of the graph line P. Graph is the graph. Y equals x squared minus 2x plus P is the point on the graph. And y equals x squared. What? I don't understand.
What is the gradient when x is 2?
So you have to draw a straight line from 2
So we
from 2, 0.
sketch a gradient. Is it like that? I'm not quite sure. Is it like that? It's kind of tricky. A sec. So when x is 2, I think it's like that. Okay. So what do you think?
Yeah, so it would be 2, 3, and 0, 0. So then the run is 2, the right is 3.
Yep. And so gradient?
And the gradient is 1.5.
Yep. 3/2. 1.5. It was 1.6. So it's probably just because I'm not great at sketching it. I think it'd be easier on paper.
Okay.
Hopefully. Okay, the gradient between 2 points, you can do a chord, sketch a chord, and do it that way. So the gradient from 0 to 10. So that's 0. 10 is halfway between those two. Okay. And how would you do question B?
Calculate the average acceleration of the car over the first 10 seconds. So, do you have to do it according to the blue line or the red one?
Blue line would be the average rate of change, from 0 to 10.
Okay. So the average acceleration of the car 10 seconds. So 1, 2, 0, 10. So 10, 29 or 30.
Okay. No, let's say 29. I'd say 28.
Okay, and then 0, 0.
Yeah.
So run is 10, rise is 28.
Maybe it is 29. We'll go with 29. And so gradient?
And the gradient is 2.9.
So that is 2.9 as meters per second squared for acceleration. So anything between 2, what was that question? That was B. So yeah, 2.8 to 2.9. So yeah, great. Okay, how do we do this one?
Question A. Calculate the average acceleration of the car between 20 and 30. So the acceleration. Do you have to make a straight line?
Yep. Between what and what?
Between 20 and 30.
Yes.
30 is in between 20 and 40 in the middle.
Yeah. Okay, what does that look like?
So first point is 28, 20 and then 8.
Yep.
And then 30 and 18. 30 and 18. And then the run would be 10. And the rise is 10 as well. So it would be 1.
And so that's 1 meter per second squared. 0.9. So yeah, we're very close. So it looked like it to me. It's difficult to tell. Average rate between 40 and 50. I think you're all right. Let me see. Between A and B. I think you're okay. I think you're okay. I think that's all right. And then 8 seconds. Time t is equal to the average acceleration. Okay, how would we do? Hang on, this is exam style question. Let me see something. Okay, so how do we do part C?
Okay. The instantaneous acceleration at time is equal to the average acceleration for the first 8 seconds. Find an estimate for the value of t. Okay, so You have to make a straight line from 8.
Yeah. 8 to...
From 8 to 0.
Yeah. So this one isn't at exactly 8. It's just in general.
So
This one is 6, yeah.
the points would be 8, 20s, 26, and 27.
Okay.
And then 0, 0. Double 0.
Yeah.
And then your run is 8, your rise is 27.
Yeah.
And if you run, do you have to run the answer?
Yeah, what would you get?
3.375. But do you have to round it?
No, that's alright. So that's 3.375. But that's the gradient. They're saying when is the gradient 3.375? It's a very strange question. Is that question C? Approximately 3 seconds. That's a strange one. That's okay. Great. Yeah, they rounded it to roughly 3 seconds, but that's kind of a weird thing. Okay, the area under a graph tells you its distance. So let's take a look. How about this one?
The velocity time versus the motion of the particle. Given that the particle traveled in a straight line, calculate the distance from 3D. And t equals 12. Okay. 0 and 12. The distance. How would you do that?
Well, it's distance is speed times time, and that for this one would be like base times height.
Okay. So do you do 12 times 25?
Not 25. What's the velocity?
15.
Yeah. That's what you do. So what do you get?
So 12 times 15. That is 180.
That's 180 meters, I think. Meters, yeah, because it was meters per second. And so the area will give you the distance. Okay, how about this one?
How long is the ramp? How do you find the width? I mean the length.
Let's see. So rolls down a ramp onto a table. So I think the ramp is this bit. And so you have to find this area.
Okay. So you have to find the gradient of that.
Area. area of the triangle.
So times height. So you do 5 times 0. 5 times 1.
Yep.
And that's 5.
And what do you have to do for area of triangle? So rectangle is base times height. Triangle.
Base.
A triangle is half a rectangle.
Oh, okay. So you do half times 5 times 1. That would be. Do you have to say in decimal?
Yeah, decimals are. Or fraction.
Okay, so times 5 times 1. That is 2.5.
Yep. So that's 2.5 meters. Let's see. How would you estimate the distance traveled from C to D?
C. The distance. So I think C is like. Oh wait, no. So C, that is 175, 60, and then. So do you have to do 300 times 60?
Well, what is the base? If that starts at 175?
175.
No. So it starts at 175. It goes to 300. And so what is the base?
125. So.
Yeah. And so distance?
Distance equals distance travelled area under the ground. Oh, so then you have to do width times height. So 125 times 60. And that is 7,500.
Or what is that, 7.5 kilometers maybe? Yeah, they did it kilometers as well. Grand. How would you do from B to C?
So C is 175.
Yeah.
B is 125.
And so what's the base?
So the base is 50.
So the base is 50. What type of shape is it?
Irregular quadrilateral.
It is a trapezium. Do you know how to find the area of a trapezium?
No.
It is a half a A plus BH, where A and B are the two parallel sides and H is the perpendicular one. So A and B would be the two going straight up. So what are the lengths of the two parallel sides?
So for B it's 40, for C it's 60.
Yeah, and the height is 50 because that's perpendicular. So that's what you have to work out. A half A plus BH.
Are you allowed to use calculator?
Yep.
Okay. Times 40 plus 60 times 50. 2,500.
Well done. 2,500 meters, 2.5 kilometers, same thing. 2.5. Great. Let's see. I just want to do quick test your best. Grand. So can you match up any of these?
Okay. So C and C.
C and C. Yeah, that's all right. Yeah. Let me see something. Okay, how would we do this one?
Estimate the acceleration at t equals 4. So we have to do straight line from 418.
Yeah, I think it's 420.
Oh yeah, 420.
Okay.
And so it would be 420, 0 and 0, 10.
Mm-hmm.
Four 0, 10. Run is 4. Rise is 10.
Mm-hmm.
And gradient is 2.5.
Looks good. That is 2.5, and that's a grade 9. Tricky stuff. And so, maybe we'll do a bit more of the trapezium stuff next time. Overall, what would you give yourself for that stuff?
I'd say half.
Yeah, it's tricky. Yeah, how was that for you, Carlos?
Yeah, it was good.
And so, any topic in particular you want to do next time?
No, you can choose.
I'll try less challenging or something. Any questions for me in general?
No.
Alright, well done, Carlos. You did great, and I look forward to chatting again next time.
Me too.
Thank you. Take care. Goodbye.
Bye.